Thank you very much, and good morning. I hope you had a nice day. I heard a rumbling tram all night, so I'm kind of tired, but I'm very happy to give the first presentation, because then I can enjoy the party this evening, right? And so today we want to talk about refactoring your code to Java 9 modules, and what we want to have a look at is how we can actually get from this, so this entangled mess spaghetti code, to something like this. So we do more jigsaw-like code, right? Because the module system in Java 9 is also called jigsaw. So this is the overview of all the things, all the Java enhancement process parts which have been in Java 9. So we will only talk about the red parts, which have to do something with the module system. Actually, it's only the two parts we are going to look at today, about how you can actually use the module system, and maybe we will have time to look at the Java linker. So this is what probably a lot of people still have. It's a big, nice monolith. So this picture I've actually taken myself at the AS Rock in Australia. And maybe from the inside it looks something like that, right? So this is all different classes, and the classes all have a lot of dependencies to each other. So when you started out with the application, you maybe had some very nice architecture in mind, and then it ended up like this mess. So we want to have a look at how we can get from a big monolith application to actually probably some smaller monoliths, right? Because we don't talk about microservices here, so it's probably just some smaller monoliths. I mean, all these nice little animals could also live in a big monolith, but they decided to actually split it up and live in some smaller monoliths. And this is probably something you would draw when designing your application. When you design your application, you usually already think in modules, right? Because we have a very limited capacity in actually drawing too many small parts on a board. We always think in like chunks, so we can only fit like a couple of chunks in our mind at the same time. So this is what we usually do. We abstract. And so if we start to actually drawing the modules, in this example, we have something which has to do with customers. We can create invoices, and we can also take pictures for the customers itself. So we draw some nice modules. And the special thing about the modules is we have the customer service here, and the invoice service can access the customer service, but the customer service can't access the invoice service. This is what we can actually draw with modules, and what we can actually do with Java 9 and make it more explicit in our code as well. So here we have the picture service, which can access the customer service to actually find out where it has to add some pictures, and it can access the camera service to actually take some of the pictures, but not vice versa. So this is how we draw our architectures. In Java 8, when we did actually program our code, we had classes. We maybe did split up our classes into packages. We maybe even put them into jars. But the problem is that the class loader completely ignores the jars. The jars are just containers for classes. And if we load all the jars, then afterwards the runtime doesn't actually know which jar a class did come from. So this proposes two problems. The first of it is we don't have any dependency graph anymore. So the runtime can't make our dependencies visual. If you actually use something like Maven, then you can tell Maven to actually spit out a dependency graph because you have it in there. But the Java runtime can't. And this actually introduces another problem. So if we have to load another class from a jar, and which is adjacent to a class we already loaded, but the runtime doesn't know about it anymore. So if we have to load another class, the class loader actually has to do a linear scan over all the jars we have there, which can take a lot of time. And if we have more than one version of a class, for example, if you use Maven or some other build system, you might end up with multiple versions of the same jar because different dependencies actually draw it in. And so what happens is that only the first version of the class is actually loaded and the other ones are discarded. So it only loads the first one we actually find, which might introduce some problems in our code if we actually expected the other class to be loaded. So this is an example application. No, it's not an example application. It's the application I'm actually working on. It's called Otis. It's there for creating invoices for petrol stations. And we now have 150 lines of code in 42,000 classes, 3,800 packages. And it's split up in 285 plugins because we are using OSGI, which already is a module system. So this 285 plugins are shown here below. So on top we have the root module, which has dependencies to a lot of other modules. And so it gets broader and broader over here. And then down there we somehow get to one of the base modules, which are the starting point, like Java base, for example, is a new module, which is the starting point, which contains object and string and int and so on. So this is a typical dependency graph that you actually get. So this desktop application actually consists of 285 different parts, which are then glued together and work as a whole one. But this application is far too big to actually use it as an example. So I wrote a nice little example application, which you can actually relate to. And it's at the veterinary. So we will have a look at our example application, which looks like that. So we have some customers here on the right-hand side. And if we click on it, we see that the customer actually has some pets here, which have a name and a date of the last visit. And we have some customer information over here. And then we have invoices, right? So after each visit, an invoice was created, and it says if they actually paid the invoice or not. So this is an example database. It always looks different each time you start it, and it's a JavaFX application. I'm not really good in writing user interfaces. You might actually see it, and it's actually my first JavaFX application, because I never actually came to use it. So we have some different entities in our application. First of all, we have our customer, then we have our different pets, then we have the visits, which are part of the application, and then we create invoices. So this is all of our entities, which you can also see in the package structure over here. We have a customer package, invoice package, pet package, and the visit package. And we have some main package here, which actually contains the application glue code to start the application. So if we have a look how the classes look like, so those are the main entity classes over here. We have the customer class, we have the data access object class, and we have some messages class over here to actually do the translation. So this application is available in English and in German. And then we have the UI parts. So first of all, we have a navigation node, which you can see on the right-hand side. Then we have the customer table, which you can see on the right-hand side. And then we have the customer view. So this is the view of the customer with the pets and the invoices. And then we have a customer info pane, which we can also see the pets actually if we double click on it. Let's quickly do that so you can actually see it. So if I double click on one of the pets, I actually get the same. Oh, if I move my mouse, weird things are happening. Nice. So I don't move my mouse now. And so we have the customer info pane over here as well, and we have a table of the pets as well. So this is all our application. So this isn't really a case for modules, right? We can split it up all in modules, but I wouldn't recommend it. If you don't have a business case for splitting up your code, your monolith code into modules, why would you do it, right? So, but then I have a friend, and my friend Al here, he has a car repair shop. So Al comes to me and says, okay, I have customers as well. And you know, I create invoices as well. And what if we can just replace all the pets with the cars, right? Customers are like that. It's all very easy for them, right? In our code, it's not that easy. We won't save a car in the pet entity. But for him, it's very easy. So what he says is, okay, what if we just can replace all these simple parts, right? From the waiting room, we just call it work items. The pets we just call cars, and we change some of the columns. So it's not the race anymore, it's a brand, and the last visit is the last repair date. And we just keep the invoices, and then we are done, right? So this is a very good case for actually creating modules out of our monolithic application, which only is one jar right at the moment. So we just have to replace the pet entity with the car entity. And now let's see how we can actually do it. What we don't want to do is sit there, go over our source code manually, and actually identify the modules. So we need some tools to help us to identify modules. And the easiest to actually identify modules is to find parts without cyclic dependencies in our application. So to our former example, we said we have the customer service, and the invoice service can access the customer service, but the customer service won't access the invoice service. So if we have this arrow, then we have a cyclic dependency here. If we don't have this arrow, we can actually use those two as separate modules. I used a very small application which is called dgraph. There are much more fancy tools out there which you can actually use. But I did go with this very simple dgraph application, and this is what it generated for me. So out of my classes, I get this nice graph, which actually is like, yeah, it mainly shows the packages and the dependencies between the packages, and all the red arrows are cyclic dependencies in one way. So this doesn't really help us, right? We have cyclic dependencies everywhere, so we can't readily identify our modules. But, right, don't panic, because this is actually how the JDK looked like before they modularized the JDK, right? So they took the source code of the JDK and they created modules for it as well. And they also had a lot, quite a lot of cyclic dependencies in the source code as well, which they somehow had to resolve and which they did resolve. So let's take another step back. So let's think about our domain. We have our entities on the left-hand side, and we have our package structure on the right-hand side, which look like each other, right? For each entity, we have one package. So this is our domain layer. But there's one important thing which is actually missing, which we don't have in our package structure. Can anybody just throw in a word what we might be missing here? If you look at the package structure and think about what's in the packages, there are many different classes in there. So what we actually should do is also have some technical layers, right? We are missing the technical layers in our package structure. So we have some classes which are part of the model, which are the entities. We have the database access classes, and we have some UI classes. We actually should split them up. So this is the first thing which we should actually do, is the first refactoring, to introduce the technical layers in our package structure. So going from the main customer package in the middle, we create 3 new packages. One is a customer.model package, one is a customer.db package, and one is a customer.ui package. And we do this for all our entities. And then our application looks like that. So we have far more packages over here on the right-hand side. So we have the DB, the model package, the UI package, and we also have an NL package, which contains the internationalization messages. And we have some additional packages. The vetDB package is a helper package, and the vet package still contains the main classes. So after our refactoring, when we run the second analysis with R2, it looks much better. So just by dividing up our classes into a different package structure, we can actually now identify some modules over here. So we have the UI module, which doesn't have any cyclic dependencies here on the left-hand side. So DB, model, and UI are now good candidates to actually create modules out of them. We have some cyclic dependencies over here, which we will just ignore for them, because those are cyclic dependencies with the main application, and we can resolve them later, but we already have some candidates. So let's take a step back and look at some of the theory for Java 9. So Java 9 was released 1.5 weeks ago on the 21st of September. The main JSR 376 for the platform module system was actually funded in 2014, but there was already some discussions going on before that. So the main objectives in introducing the module system was reliable configuration. Sorry, we want to replace the class path, because I already said before, like if you have multiple versions of a jar on the class path, it can easily look like hell, right? You don't know which one of the versions are actually used. And we also want to solve another problem, like when we have a public class in our jar, it's always accessible from the outside. We have some things which we can actually do is like calling a package internal and hope nobody will access any classes in this package because it's internal, but it didn't work out really well, right? People were already using the Sun classes as well and the Sun packages, which should not be used. So with the platform module system, we want to make this different. So public public class won't mean it's publicly accessible anymore. And scalable Java SE platform, so it would also be modularized as well. So you only have to use the modules you actually need. So you don't need Core anymore and all these other stuff, which you actually don't need. If you don't have a JavaFX application, you don't need JavaFX. You don't have to bundle it into your application. Greater platform integrity, legal access for internal APIs. So internal API can then really be protected in modules, and we will see in a minute how we can actually do it. And improve performance as well, because what they wanted to do is actually make the runtime aware of the modules. So you don't have this linear scans anymore. So the runtime knows, okay, I loaded this class from this jar. So if we have to load another class, it's probably in this jar as well. So we don't have this linear scans anymore because we build up a dependency graph. And there's also Java 10. Java 10 is not like 3 years away. It might actually be released next March 2018, but this is just a proposal. So what they want to do is to actually release the features when they are ready. So there might be feature releases every half year with update releases every quarter and long-term support releases like we have them right now every 3 years. Well, it's a very nice thing is that more and more code moves to the OpenJDK. So on the OpenJDK, everything is open source, so you can actually look at the source, you can collaborate on it, you can become a committer for the Java language itself. Also, mission control and flight recorder will be open sourced as well. It still demands you to actually have a commercial license in Java 9, but that's not really valid anymore, so it's now GPL and you can freely use it. And the Java Enterprise Edition moved to the Eclipse Foundation and is now called EE4J. So this is what comes next. So back to Java 9 for now. What we have to add, the only thing we have to add to our jars to actually make it a module, or to our source code to actually create a module from that, is a module -info.java. So this might remind you of the package -info.java. The reason for that is that a minus is usually not allowed for a class name. So this is still a Java class, but it's a special class. And by using the special name, all the tools which are not yet aware of Java 9 will just ignore anything which is called module -info.class. So this kind of makes it backwards compatible. So if you have a module class in there and you run it on Java 8, if you don't use any Java 9 classes, you can do that, and it will just ignore the module information. So modules ideally just form a picture like this one over there. So they just, fit into each other like a jigsaw. To create a module, you create this module info Java directly in your source folder, so above all the packages. And what you write in there is a module, and you give it a name, which should be the reverse DNS name. So if you're a company registered a DNS name, you should put the reverse DNS name, like, I don't know, Google, and then your project name, for example. To make sure that your module name is really unique. So this actually will help it. If you only use it internal, you don't have to do it. But if you ever want to publish it, then you should do that. And then we have some new keywords here, which are requires. So this is how we declare dependencies to other modules. So here goes another module name. We can export packages to make them actually accessible from the outside. And we can use services, and we can provide services. So we will have a look at this in detail later. What is very important here, those are restricted keywords. So you can still use module as a variable name in your own code, because those are only keywords in the module info.java. So those are not real global keywords, like, for example, import or something like that. You can also put actually annotations on modules and have imports in there and all this fancy stuff, but this is more advanced. So a module from the inside looks like that. So we have a module called model over here, which has two packages, a DB package and a util package. And here we have the module definition. The module is called model, and it exports only the DB package. We have another module over there, which is called UI, which requires the model module. So the UI module over here has this requires clause over here, so it has a dependency on the model, and it exports its table package. So what we can't do over here now is access something in the util package over here from our UI module, because it's not an exported package over here. So anything which is public in the util package is still protected inside the jar file, inside the module, because it can't be accessed from the outside. So this is a very nice thing which we actually have with modules. So let's have a look at our entities again. So we want to replace the pet entity with the car entity, and we want to keep all the other things. And we already had some analyzers running, which showed us that we can identify some of the modules over there. And so let's think about some new modules. What I do over here is probably nothing which you want to do in production. So I have this business case that they just want to replace the pet with the car, and I can keep everything else more or less like it already is, right? So I don't create packages, modules for each of the entities, which you would probably do in production. And so our new modules would be the model module, the UI module, and the pet module, and the vet module. So in the model module, we put everything which we had in the model package, UI, everything in the UI package, customer, visit, and invoice, because we want to have the pet separate. In the pet module, we put the model and the DB and the UI. So we don't have two separate modules over here, like a pet model and pet UI. We just put it in the same one, because we want to exchange it with the car later. And then we have our main application module, which glues everything together. And what we have to think about when we actually create the modules, that there is no split packages allowed. So what is a split package? A split package is the same package. So we have the customer package here, which is contained in the UI module and in the model module, right? So this is not allowed. You can't do that. So you have to name them differently if you actually do the refactoring. We already did this, so it's called customer model and customer UI in our application already, so we are fine. But you shouldn't do that. The reason for it is packages are already also represented in the class loader, and so two of the same name are not allowed in different modules. So let's actually do the refactoring here and create some modules. Let's go into the source code. So this is my old application, right? It's our vet application with all the packages in here. And we now want to split it up into the modules we just designed. So we create a new Java project here. And we call it model. And I put some suffix in the end. This is just the steps of the different refactoring, right? It's not a version number or something like that, because modules don't really have a version number. So we say we want to use Java 9 over here. Anything else? No, I think that's fine. So we have a new Java project over here. So this is going to be tough. I shouldn't really touch my laptop, but I have to do some coding, right? Let's try that. And what we do over here now is in the model, we put everything with customer and with the invoice. We skip the pet and we use the visit as well. And we got a nice helper package over here. We just copy them and move them over into our new package structure. I already need the resources folder because in there we have some of the things we need to actually generate the entities on runtime. Let's see, I don't need the translation packages. This will go in the UI, and I don't need the main application package. I can just delete that. And sorry. What we want to do now is actually create a new module info, so the module descriptor file. We create a new file directly here in the source folder. This has to do something with the connector, I guess. And now it's back. And now it's gone. That's very funny. Module info.java. So we type in the module keyword, and then we give it the same name as the project name. So they have to be the same, the folder name and the module name. And then we have some requires clauses. First of all, it's java.base, which contains our object class, our string class, and so on. And we have some more requires to Java fx base, because inside my entities I do some Java fx binding directly. I was being a bit lazy. So if you want to find out which modules you actually require, then have a look at the Java doc of Java 9, look up your class, and at the class you also find in which module it is now. So it's now contained in the Java doc. So you can find out which modules you actually need. And then we want to export some of our packages. And we have this customer DB packages and all the other packages, because we need to use them from our UI module. So we have to export the packages. So I'm being a bit lazy and have a template over here, so I don't have to type everything. And now we see this. This looks like a game, right? You want to play a game? All right, I actually forgot one of the packages, which tells me, which tells me the red marker over here. I forgot this package to copy it over to the source folder. So let's quickly do that, because I copied the wrong folder. So that's the right one. So then I have one error marker over here in our visit database object, because it directly did access. You will see it in a minute, I hope. So because it did directly, don't move the mouse, don't move the mouse. It did directly access something of the pet, right? The visits did access something in the pet. We can't do that anymore because it's not in our same module anymore, and we don't want to have a dependency to the pet because we want to replace it. So this sometimes happens during refactoring, and for now we just comment it out, right? And we probably put it to do over here to actually remember it in a later refactoring step, that we have to think about what we can actually do about it. All right. So this is our first module over here, and then we create I created another module which is called the UI module, which is already ready, which contains all the UI packages over here and a nice module info. And this is kind of not funny. So, and we require our module we just created over here, right? So we have a requires a dependency to the other module we just created over here. And then we have to create another module, which is called the pet module. So I think we actually skip that for now, because it isn't really fun to actually do this when it's always missing. So let's have a look at the complete result over here. So we have 4 different modules now, which is the pet module, the vet module, which contains the main application class, the vet services application class, and the UI module and the model module. And if we actually start this application, let's have a look. If I can start it. Cannot find the module. This one has errors as well. So that's a problem, right? The IDEs are not really ready right now to actually do some module application stuff. Okay. So you just have to believe me for a moment that it actually runs now as a modular application with this 4 modules in there. I don't really want to touch my laptop. That's not really funny. All right. Let's move on. So another problem we have is that we have a dependency not only from the visit DAO to the pet. We also have a dependency from the customer view, because it displays the pet a customer has. So we have a dependency from the customer view directly to the pet table, and from the pet view directly to the customer info pane. To inside of the pet we can show the customer information. So this is our one module over here. It's the UI module, and this is our pet module over here. So we can't have this cyclic dependency anymore. So we have to think about something to actually resolve it. This is how it did look in the code. So we are creating tabs in the view to actually have pets and invoices displayed in the customer view, but we can't do this anymore. So what I did for now is actually comment it out. I wanted to show it, but it's not really easy to show when the display doesn't work. So this is the code I commented out for the moment. So the state we have right now is that in the pets tab, nothing is shown. It's just an empty tab, because from the UI, we can't access the pets. So what we can do here is resolve the dependencies by using an interface and using a service. The service loader has already been in Java since version 6, but it was kind of hard to use, so you had to create a meta-int folder, and inside that you had to create a file which had the name of the fully qualified name of the interface, and then you put in all the implementations in that file. So this did work, but it was kind of hard to actually make it right. And what we can do now with the module system is using services much easier. So from our customer view, what we do now is create a new interface, which is called the tab service, and it has a method called create tabs. And in our pet module, we create an implementation for that, which is called pet tab service, which implements the tab service interface. And this now has access to the pet table again, so it can show all the pets inside the tab again. And the glue code here is the service loader. So the service loader will load all implementations of our tab service interface, so I can use them again in the customer view. So in the module, we add some users clause. So with the users, we say we want to use a service, consume a service, which is just the interface name, customer view tab service. It should be the fully qualified name. I just abbreviated it here. And in the pet module, we say we provide an implementation of the customer view tab service with our implementation class, pet customer view tab service. Again, should be fully qualified names. So this is the next thing I actually want to do. I will try to do very gently. right. So let's have a look at the status over here. So I should actually have some task tag over here. Yes, there it is. In the customer view, I have some task tag over here, which is green, right? Green is good, right? Green is a passing test. So which says over here in German that I should actually introduce a service over here because I commented out all the code which creates the pet node. All right. Do I have a different USB port I can actually try? No, I don't. So what we want to do here is create a new interface. Create a new interface, which is called customer, and we put it in the SPI package for service provider interface, and we call it customer view tab service. This is our new interface. So there's actually some recording of this talk if you actually want to see it without these interruptions. There's already some recording over there. So we have a new method over there which gives us back a list of tabs, and which is called create tab. We pass in the customer view and we pass in the customer entity, so we have some relation over there to actually find all of our things. Oops. So, list tab, it was called tab, right? Wasn't it? It is called create tab. Returns a tab. Yes, it should be a tab. So I should actually learn some more shortcuts, because if I don't move the mouse, everything works. But it doesn't if I don't. All right. That doesn't make much sense, I think. Does anybody want to go on with this funny display? No, I don't think so, right? So this is what we actually get out over here is we have in this SPI, we have this customer view tab service with our code over here, which creates the tabs, right? So in our pet module, we have the implementation, pet customer view tab service, which now, so this time I didn't move the mouse, which actually creates all the tabs over here. So we, with the service, we will get back our pet tab inside the customer view. And now let's go back to the slides. And the next refactoring step would be to actually create our car entity. So what I did simply do is very easy. I copied the pet module and I renamed it to car. I renamed everything which is called pet. I renamed it to car. I introduced some new fields for the brand and for the build date and so on of the car. And then I introduced a new module which is called the app module. And in the app module, I have my main application class, which does all the gluing logic. I did throw out all the parts which had to do something with the web application. Like, for example, my web application was blue, and I wanted my car application to be red. So I refactored out the parts, which actually draw in the CSS file, and I refactored it into a service. So we have a new service now, interface, which is called the application configuration provider, which contains a getName method, a getTitle method, the CSS method, a new icon method, and so on. And then I created 2 new modules, the vet app and the car app module, which implement the application configuration provider and provide them as service implementations as well. So this is the next refactoring step I did take. And the result for it is now 2 different applications over there, which are just created by different modules. And so we have this vet application over here, which still has the pets with the race and the last visit. And we have the cars over here with the car name, the type, the year, color, last visit as well. And the application, the customer which owns it, right? So this is 2 different applications. They have a different icon over there. They have the different title. This is all implemented by just a simple service. So if we visualize our modules, and we have this structure over here now. So you can just use some tool like that, for example, and visualize the modules you have with all your dependencies. So we have a new module here in the middle, which is called the app module. And the vet module does require the app module and does also require the pet module. And we have the car app here, which requires the car module in addition to the app module. And everything else is just the same. We have the UI module over here, and we have the model module over here. And down there, we have all this Java base and JavaFX and so on. So quickly, deployment. Deployment, the main thing is if you want to compile something, you don't have the class path anymore. You have the module path, and you don't have the source path anymore. You have the module source path. So this is mainly how you compile it. What you should do here is put the excellent exports here to actually make sure that everything you have in your public API is actually also exported in the packages. So otherwise you will get a warning over here. You create the jar file as well. So the only difference is that you now have the module info.class in your jar file as well. Then you can run it. You don't put the minus CP for the class path anymore. You put the -p for the module path and -m to actually start the module over here and the main class inside there. So this is how you start your application. Another nice thing is the Jlink. So now you can actually link only the modules you have requirements on or transitive requirements on into your application. So no Corba in there, no Swing in there, nothing else in there. You just say you want your modules, and it will output a native launcher. So on my Windows system, it will output a batch file to actually start the application. And it contains the full JRE, but only the things you need. So on my system, it's around 40 megabytes now. So this is everything I need to run my application. And so in summary, we got from this more or less entangled mess to actually this nice module graph, right? So it's far easier to read. And the refactoring steps we did take were very easy. So we refactored our package structure. And what you actually should also do is always apply some domain-driven design principles and some design patterns, which will help you to structure your code to make it easier to actually get out some modules in the end. Then we analyzed our dependencies. We identified and created some new modules. We moved our code to the new modules. We resolved any dependencies we still had to modules which we didn't want to have with services. You can also create plain interfaces if you can access them as well. And what I wouldn't want to recommend to you is actually do this, to use your monolith and divide it into many different modules, right? So because if you don't have any business need, if you just want to refactor it to modules because it's nice and cool and fancy, you know, the only thing a big bang rewrite guarantees is a big bang, so you might end up in a big mess over there. So my experience is that creating new modules on your own business needs really helps. So our business needs were, we had a new customer which has different needs of modules over there, so we split it out some of our existing modules and moved only the functionality the new customer needed to a new module, or we had a new service provider which had some new interfaces we needed to implement. So beginning with a monolith application 5 years ago, we now have 283 plugins. We didn't do a full rewrite, we just only refactored when we had the business need. You always have to think about the module boundaries, because your new module descriptor also becomes part of the API. So like your IDE might propose to add a static somewhere in your code. You shouldn't do that. You should also have to think about the modules. So your IDE might propose to just add an export of the package if you need it, but you still have to think about it. It's part of your public API. And refactoring usually is very easy by introducing new interfaces and services. Usually there's not many hard problems involved. So the advantages of modules over monolith is that your architecture is much better reflected in the modules with very clear boundaries. You can hide your public classes, and you can even replace some single modules, which you also had in microservices. The module path is much more robust than the class path, so on startup, it will try to see if all your dependencies are satisfied, so you shouldn't get that many no class dev found errors after like X hours into the application runtime, because then it tries to load it and doesn't find it. There will be better tool support in the future, like which dependencies might I be missing. The deployable units are much smaller if you use Jlink, the Java linker. And you have a better startup performance because it's much easier to actually explore all the dependency graph than it is to load some class passes. All right, so this is the end of my talk. There's much, much more into modules. So there's a nice book, which is already published in the final version, Java 9 Modularity, which you can read. And the slides and the full code are up on my webpage. There's also a link to a recording where you can actually follow the full refactoring steps, which I'm very sorry I couldn't do here, but that wasn't so easy with the Beamer. If you have any questions, you can also contact me on Twitter, or you can just find me throughout the conference. Just feel free to talk to me. I know it's always sometimes hard to just say hello to a foreigner, but now you already know me, right? So you can just say hello. That's totally fine if you have some questions. And do we have any questions right now? In the front row.
First of all, you said Java dependence? Because, well, I imagine like you have a couple of classes, this is fine, and I have like a lot of production code with a lot of dependencies just on Java itself, and I will not go for each class to docs and figure out where it lays. It just doesn't make any sense.
Yeah, like I said, there's a couple of tools out there, which some of them have to be paid, which you can find in the slides over there. Maybe have a look at them. And they will help you to actually restructure your code, and maybe they can also do it automatically, if that answers your question.
Yeah, it does. And I have another one. So this thing makes perfect sense when you're talking about desktop applications or the ones that are running on the same server. But if you have, like, for instance, distributed stuff in some way, just by including, I mean, it still makes sense, but it doesn't make that perfect sense, because just when you include the jar files or not include the jar files, you will, like, to the deployment itself, you will have this dependency or you will not have this dependency. And basically you will have the, like, failure right away.
I don't understand the question.
Okay, never mind. Maybe let's take it offline.
All right. So one question over there, and then we have to finish it up. Yeah, it's you.
The question was, you saying that it's well aware of where to find and what module to find a class, so there is no linear scan. Is there some effort from programmer on that, or it just happens automatically?
Yeah. So the question was, if there's any effort we need to take to actually make sure that the runtime will find all the dependencies, and yes, it does it automatically, so it scans all the jars on startup, finds all the modules inside there, and also registers all the classes it finds in there. So it registers all the classes on startup, which you have in the modules.
The lookup doesn't happen during the runtime, it happens during the start.
Well, the class loading happens at runtime, but the lookup not. No, the lookup happens on startup to actually make sure. All right, then thank you very much for attending my session, and have a nice conference.